Okay, so let's restart. Okay, so far we learned about what we learned so far. We learned about transformer. We learned about how electrical has been transmitted. We are now in the middle of discussing about the characteristics of alternating current. So alternating current is a current flow varies magnitude and direction with time. Some example here, we can draw sinusoidal, or you can draw square wave. Okay, as long as the current as a positive and negative value is alternating current. Okay, alternating current. I versus T. Okay, we talk about the equation of alternating current. Okay, students, can you hear me, right? Can you hear me? Can see the file?
Yes. Yes.
So this is the equations. And the most important term, what is meant by root mean square? Okay, frequently asked in exam about AC is what is meant by root mean square. So what is meant by root mean square? This is the definition you have to remember. What is meant by root mean square? Okay, root mean square value. A root mean square value of an AC is defined as equivalent value. This is one mark. One mark. Equivalent value of DC. One mark. Which would dissipate heat at the same average rate across a given resistor. This heat at average rate. This is one mark. Okay, it would mean square value. Okay, yesterday I told you a story how the power must be the same. They equate it. Okay, then they found these two formulas. Okay, the RMS value is found to be I naught over root 2, V naught over root 2. Okay, so today we're going to discuss. Let's be continue with this first. So I RMS. So we can see here the PT, the power is the same. So I naught T R should be equals to I squared R. I for the DC is constant. Here they put mean because average current, because AC current changing up and down. So we put average, square of the average. So both same. So when you equate them, we found to be root mean square value is the equivalent to the direct current value. Okay. So now how they got this formula is the square. So from here, from here we find the root mean square value. It's going to be I squared is what? I naught squared sine squared omega t, because we sub in the I formula inside. Then I naught squared sine squared omega t, the average of sine squared, is found to be half. Okay, the average of sine squared is actually the, let's say what I'm saying is sine is like this. The average out, of course the value is maximum A naught, but we want to find the average. The average is we integrate it this area up to period. Integrate means what? We find this area, and this area we make it like we retreat it like a square, not say like a rectangle shape, and this is the average value within the period. So this area we transform into a rectangle. The height of the rectangle is the average value. Okay. So this area is equals to I average times the period. Okay. This area is the integration of t to 0, the I dt. Okay, I dt. Then how do you get the I average? This integration you just divide by 1 over period. 1 over period, you get the I average. Yeah. That's what they did here. Okay, the integration. This is your area of the entire graph, and 1 over ty we divide by period to get the average, because we want to change this area into a rectangle to get the average value, because the current year is changing, going up, come down. So we want to get the average value. Okay, so we want to find the average value. Okay, the average value is found to be only for the sine law. For the sine, average is found to be half. So here we throw out the sine squared omega t is half. We got this equation. I think this 1 over t integration of t what do you call limit t0 sine squared omega t. If you go in maths, I think this is going to be the half page of working. I think to get half. Okay, this is maths process. But physics, we don't not really testing how it derive. You accept these two formulas. Okay, so I naught over root 2 is I RMS, V naught over root 2 is I RMS, as long as it's a sinusoidal wave. As long as it's a sinusoidal. Okay, sine. Okay, now what we're going to do, we want to get formula for power. Okay, V changes sign. I also changes sign. Power going to change what? Power going to change what shape? Sine squared omega t. Change to sine squared omega t. Correct, right? T equals to IV. I is I naught sine omega t. V is V naught sine omega t. So I naught V naught sine squared omega t. So the power varies with sine squared omega t. Okay. So the graph going to be like this, sine squared. Like I think you have come across with the drawing sine squared, right? Where I think in SHM drawing what versus what, you got a sine squared. SHM, kinetic energy and potential energy time. One of them can produce a sine squared graph. Sine squared graph. Okay, period long. Like an M shape. Like an M shape. So the power dissipation across an alternating current is like the power going to vary like this. Sine squared graph. The peak power is I naught squared R. Yeah, that's the peak power. Okay, well, now we want to get the average power, because we want to get average power. Okay, I equals to I naught sine omega t. The instantaneous power is given by, power at a particular time. This is the formula. I squared, we put I squared sine squared omega t r. We find the mean power. We are focused to mean power. Mean power, just we find the average power, okay, sine squared omega t. So half I naught squared r. Okay, how do you get half? You see, mean power, the instantaneous power is this, I naught squared sine squared omega t. Average power, we average out this I naught squared sine squared omega t. I naught is constant, so we can put it out. We can just put it out the I naught squared. We just want to find the sine squared omega t average. Sine squared omega t average, we already know is how much? Sine squared omega t average is, sine squared omega t average is half. So we straight away put half. So we got this formula. This is the formula. So, but I naught over root 2 squared is actually I RMS. So I squared RMS. So this is the average power. Average power is I squared R, but the I must be I RMS. The average power can be V squared over R, where V must be what? V must be V RMS. The average power could be IV. I and V is what? Both are RMS. So when come to average power, we can use the same formula IV V squared over R, I squared R. But remember, the I and V must be the RMS value. RMS value is the average power used. Okay. If the question asks peak power, peak power, then if you use IV, the I and V must be what? Must be the peak value. Okay, must be the peak value. Okay. Okay, so this is the derivation for power, for power up to power. Okay. So this derivation for sinusoidal alternating current. Okay, sinusoidal alternating current. If current is voltage is sine, current is sine, power is sine squared. The average power is I squared R, where the I is the RMS value. Okay. Any question from here? Okay. So AC is little trickier compared to DC. DC, if they ask what is power, I squared R, only have one I, we know is constant, so we substitute. But now in AC, they can ask, they can try to confuse you. They can ask peak power, they just can ask power. Power means average power, I consider average power. Peak power use all the peak values. Average power use all RMS value. Okay, so you should know when to use RMS, when to use peak. Okay, so let's go one example. Okay, look at this question. Please, I give you 1 minute. Try to work out this question. You should get these 3 answers. If you got these 3 answers, okay. Okay, so you get the answer, the first answer. The domestic electric heater operated at 240 volt peak value. Oh, this is the peak value. 240 is peak value of AC. Supply an RMS current of 8 ampere. Okay. They give voltage peak value. The current they give the RMS value, 8 ampere. Oh, no problem. If they give peak, we can find RMS. If they give RMS, we can find peak. We know the formula, right? V RMS is equals to V naught over root 2. And same thing go for I RMS. So we can find, if they give peak, we can find RMS. Okay, if they give RMS, we can find peak. Okay. So assuming the heater is purely resistive, calculate the resistance of the resistor. So you want to find resistance, what formula comes to your mind? Of course, R equals to V over I. Okay, which V and I to be used? Both can be used. If you want to use RMS, both make sure RMS. If you want to use peak, both make sure peak. But don't get confused. We go for RMS. Only when they say peak, we go for peak values. So we have both. We go for RMS. VRMS, IRMS. Okay. So then put the value lah. VRMS peak, 240. So yeah. So VRMS is what? 240 over root 2, right? And IRMS is what? IRMS 8. So we put 8. You should get the answer. You get 21.2. Okay, you should get 21.2. So clue here, VOI, both RMS. Okay, V, mean power. Mean power, you can use IV if you want. IV, okay, we can use IV. Both RMS value, BRMS, IRMS to be used. In this case, yeah, calculate accordingly. VRMS, IRMS from above. So the current is 8. The VRMS is 240 square root 2. Get the answer. 1.36 kilowatt. Okay. And the next, third one. Maximum instantaneous power. Is the maximum instantaneous power. This is your peak power. The peak. So peak power is what? You should use I peak, V peak. Okay. So both must be peak one. So yeah, change accordingly. I RMS, you know. So 8 times root 2, you got a peak value for I. V0, we know already. 240. So you get the answer. Watts. Kilowatts. 2.72. Okay. So this tells you what? See, if you connect it to the AC or power supply, 240 volt of peak power, peak voltage, the power in the, maybe you connect it to a laptop, connect to the laptop, the power to the laptop will go what? Will reach from 1.3 kilowatt to 2.72 kilowatt, changing like a sinusoidally, the power. Okay, power. So this power is enters into the laptop like this sinusoidally. But if the power go like this, your laptop screen become very bright, less bright, very bright, less bright with the 50 hertz. Okay, but we never see that in your laptop. Why? They don't directly send this power to the laptop. They do what? They do something called smoothing to make it perfectly like to stabilize the power. Later we will discuss what is meant by smoothing. Okay, so any questions from here? RMS value. Introduction to the RMS value. Okay, remember these two formulas. Okay. Now, how do you find RMS value? How do you find the RMS value for a square wave? This is our discussion now. Okay. One example. Let's say we give I versus T. It's a square wave. Okay, it's a square wave like this. Okay. Square wave where up is 2 ampere, down is -3 ampere. I'm just giving a different values. Up is 2 ampere positive, down is -3 ampere. Let's say square wave. It's a period. Find the IRMS. Okay. How do you do this? Okay, this is something what to say tricky. Okay. So how do you get RMS value? You can't remember if it's not sinusoidal. Of course, you can't use I0 over root 2. I0 over root 2 is IRMS, not valid anymore. It's only for sinusoidal. This is a square. So how do you find it? Okay, how do you find? We work from the backward. First, square the graph first. Square the graph first. Square it. We work from the back. Square it. This graph, you just square the graph. When you square the graph, how the graph when it looks like? 2. This is T over 2. Assume T over 2. 2. Square it become what? Become 4. Right? For example, you see 2. When you square it, it becomes 4. Then 3. The second square, you square it, become what? Become 9. Here become 9, correct? So the graph changed what? The graph changed to 4, then go up, become 9. Become 9. 9. Okay, this is for a period. Just go for a period. One period is enough. Okay, this we already square a graph. This is the area of the graph. Okay, and what do you call not a perfect rectangle. Okay, now we want to min the graph, min the value. So you want to find what? You want to find mean square value. Okay, how to get min means what you are trying to do? Min means we're trying to convert this area. You're trying to convert this area to a nice rectangle. You're going to change to like a rectangle. You change this to a rectangle, kind of like a rectangle shape. Okay, the peak value here is the mean squared value. What is squared? This is the mean value. Mean. We average out the current law. The first half cycle was 4 ampere. The second half cycle is found to be 9 ampere. The square value, we mean it, we average it. So this is called mean square value. So when it becomes mean square value, the area we tend to become like a square. So the original area was like this. It tend to become like a square area where the maximum, the height is mean squared value. Here the height is 4. Here the height is 9. And we know this is t over 2. This is t. You know this is t. Yeah. Okay. Can you find mean squared value? The magnitude? We can find one. What is linked between these two area? What is same? The area same, right? The area same. Okay. Now let's find the area. So first area is what? First area is what? 4 times what period? T over 2 plus 9 times. What is the width for the 9? Another T over 2 should be equivalent to this rectangular area, which is I mean squared value multiplied by the period. Okay, now find the mean squared value. It's what? How much you get? I think all t cancels. All t cancels. T cancels. So you get what? 9 plus 4. How much? 13, right? Yeah, 13. So 13 over 2 is your mean squared current. Okay, now only another one step. Last step we got to do what? We did square, we did mean. Now you do what? You root it. So I RMS is just root this value. It's 13 over 2 ampere. This is the answer. So the I RMS for this type of graph, for this alternating current, which gives 2 ampere for the first half cycle, negative 3 ampere for the second half cycle, the RMS value is root of 13 over 2 ampere. This is how you work out RMS value for a different AC shape sources. What do you have to do? You work from behind. Square the graph first. Just the value, just square it. You get the shape. The shape going to be uneven. Then min the value. Min means what we're going to try and do. The uneven shape, we're going to make like a rectangle. The height is the mean squared value. Make the area same. So area for both same, we get the mean value. Then the last step is just easy, just root it. Square root. So you square root the value, you get the root mean square value. Okay. Any questions? Before I give you another one example for you to try. Okay, hope can. Okay, let me give you one question. I want you to try. Okay. Okay, let me play this. Play this. Okay, I'll give you another one example. Give you one here. I'll give you another one longer one. Here t power of 4. Here t. Here 2 ampere. Here negative 2 ampere. Okay. Yeah, okay. This time with current. Okay, find I RMS for me. Okay, 1 minute for you. I'm expecting you to give me the answer. IRMS, how much? Spend 1 minute. Work from behind. Square the graph. Find the mean. Mean equate the two area. Then just root it. You get the IRMS. I give you 1 minute. Okay, class. Anyone got the answer? Anyone can try answer? You got your answer. Marwan, you got your answer.
No, not yet.
Not yet. Okay. Take some time. Take another 1 minute. Come on. Shinho, yeah? Shinho? Shinho, you got your answer. Shinho? Shinho not here. Gavin, what's the answer? Gavin?
Is it 2?
So you got 2, Shike, what's the answer?
I got 2 also.
Got 2, Okay. Yes, we see, So first we square the graph, We square the graph. So when you square it, what happened? You square the area, So square the area. I think the entire, this area, if you square it, you're all going to become like this flat. Yeah. 4, 4 with period. So 4 with period. 4 times t already. We are actually looking for a rectangle. We also want to change this to a rectangle, but it's already a rectangle. Means what? The 4 is I mean squared value. It's already a rectangle. It's already average out. So I root mean squared is root of 4. Yes. So you got 2. Very good. This is your RMS value, 2 ampere. Okay. So remember, on top and bottom, if same number, okay, same number, up top is 2 ampere, down is -2, same number, which is quite common to give like this. The RMS value is going to be same as the peak value of 2 ampere. Okay. The RMS going to vary if the peak here and peak here is different, up and down is different, then going to vary. Okay. Okay, now, yes. Okay, so this is RMS value. Okay, so you should know if they give any shape, you must square the graph, change the uneven shape of the graph to a rectangle. The height of the rectangle is your mean square value. Then you root it, then you get the RMS value. Okay. Okay, good. Okay, so now we go back to the slide. Okay, so we done this, we done the period, this is all we done. Effective values we done. Okay, this is the long derivation to show the VRMS. Integrating the sign, you end up getting like a half page of working to get root 2, but not necessary. Okay, now let's give a try. 1 minute again. Please do this question. Find the period, frequency, angular frequency, peak value, peak to peak value for this alternating current. Period how much? Period is easy, 2 seconds. Check always the 2 millisecond. Frequency, 1 over 2 millisecond lah, 1 over 2 millisecond. Angular frequency is what? Angular frequency is 2 pi over t, so 2 pi over the 2 milliseconds lah. Milliseconds change to second, you get a period. Peak value, the maximum value here, the 3 ampere. Peak to peak value, of course 3 to -3, so 6 is your peak to peak value. So I think straightforward, right? Okay, so this what should be getting in your working, right? 2 milliseconds and so on. Okay, we skip this. Go to the next one. This one. Another sinusoidal graph here. They're asking find the root mean square value. So because it's sinusoidal, we can use I0 over root 2. So we need the peak value 6. So 6 over square root 2 gives you the RMS value. Okay, go to another one. This is a CRO display. What has been shut down in this appearance? What value has been shut down in this appearance? Anyone? What button has been shut down?
The time.
Again, or time base? The time base has been shut down. Time base shut down, so horizontally you can't show anything. Y gain as is on. Okay. So from here, this is your peak to peak, up to down is your peak to peak, covering 6 boxes. So peak voltage only 3 boxes, should know. So they're asking what is the peak voltage. The Y sensitivity is 10 volt per division. So peak voltage, of course, 3 box only. So 30 volt, 3 times 10. Peak to peak, of course, 60 60. RMS voltage, you know peak voltage, so peak divided by root 2, you get the RMS voltage. Only can be used this formula if they say sinusoidal. You must wait for sinusoidal. Sinusoidal, you can use that formula. Okay. Okay, now another what do you call AC? What is the amplitude? What is the RMS value? What is the frequency? Okay, let's give a try. The diagram shows a variation of an alternating current. The amplitude, you know, is 10. The RMS value, the 10 divided by root 2, you get the RMS value. The frequency of the power supply, how to find the frequency of the power supply, get the period, 1 over period, you get the frequency, millisecond. The phase at t 15 milliseconds. At 15 milliseconds, what is the phase change? So from 0 to 15. So how do you find phase? What formula to find phase? 135. Phase is, because it's in terms of time, so t over period times 360. Or you can use t over period times 2 pi. So the same formula to be used to find the phase. So at 15 minutes, at the 15 seconds, what is the phase from the beginning to the end? So time is 15, period is 40 times 360. So you get 165. Okay. Okay. Now your turn. Okay. Please, I give you 2 minutes. Try to do the working for this. Please get these answers at the bottom. 2 minutes for you. So you must know when to use RMS, when to use peak values. So the kettle stated 240, 1440. So they want the RMS current. So what formula do you use? You know power, you know voltage. You want to find current. So I think better use P equals to IV. No? So find the I RMS. So it's P over V RMS. The P should be the average power. This is your average power. So 1440 divided by VRMS. VRMS is what? VRMS is 240. 240 is VRMS. Whatever written on the device, the reading is actually all RMS value. Okay. So 1440 divided by 240, you should get 6 ampere. Get 6, yeah. 6 ampere. Okay. So once you get RMS current, you can find the peak current already. So I RMS, I peak is what? I RMS times it root 2. So 6 times root 2, you should get the peak current, 8.49 ampere. Third, the peak potential difference. You know RMS voltage, so you can find the peak voltage, right? So peak voltage is what? V RMS multiplied by root 2. So 240 times root 2, you get the peak voltage, 339. Okay, peak power. Peak power is how much peak power? Peak power, yeah, peak power is I peak, V peak. So you know peak current, peak potential from B and C, which is 8.49 times 339. You get the peak power, 2880. Next, average power. Average power, just P equals IV, both RMS value. Okay. So use both RMS value, you get the answer. You get 1440. Okay, now something I never told you. Look at D and E answer. D is 2880, E is 1440. Okay, can you make a link between peak power and average power? Average power is how many times of the peak power? Half of the peak power, right? The average power is half of the peak power. One pass came out, asked you to prove this. Prove that average power is half of the peak power. 2 marks question, if I'm not mistaken. How do you do this? How do you prove D and like average power is equals to half of the peak power? From RMS value, you should prove lah. Okay, any question from here? Let me show you this proof after this. So I think this is straightforward also, this question. Any questions? Okay, so I assume you understand. So you go back here. So how do you prove average power is half of the peak power? So the average power is what? Is I RMS times V RMS. So I naught over root 2 times V naught over root 2. So you got I naught V naught over root 2. This is your V naught over 2. This is the working. The average power is half of the peak power for sinusoidal AC. For sinusoidal, only for sinusoidal. Okay, so this is, remember, depth derivation. Okay. Okay, so next. Okay, now this question also a very good question. Okay, I can say this is the last question. Okay, give a try. 2 minutes again. It's slightly a different what do you call pattern, because they give equation for current. You need to interpret a lot of things from this formula. Give it 2 minutes. Come on, work out the answer for this. If you can give me the average power, if your average power answer correct, it's a chain reaction. If the average power correct, I think the answer from A to D is correct. Okay. So give me take 2 minutes, try to draw everything. Just give me the answer for the average power. Okay, so you got your answers. So how do you find the frequency of alternating current? By using the omega, right? By interpreting this. This is your peak value, 8 is your peak value. This 100, this is your omega t. So omega is 100 pi lah. 100 pi is your omega. So you can find frequency. Frequency, what? 2 pi f is omega, right? So f is omega over 2 pi lah. 2 pi. Omega over 2 pi is your frequency. So omega we know is 100 pi. So 100 pi divided by 2 pi. So you get frequencies 50 hertz. The interpretation from the equation. So 100 pi is your omega. Peak voltage, you know this is your peak current. Peak voltage 240 VRMS. So we can find the peak voltage lah. So 240 root 2, you get a peak voltage. IRMS, you know peak current 8. So 8 divided by root 2, right? 8 divided by root 2, you get RMS. Peak power is what? Peak power is I naught V naught lah. I naught V naught. So you know peak voltage already. You know, yeah. So I naught is 8. Peak voltage is 240 root 2. You get the peak power. Average power, very easy. Whatever peak power you got, the peak power divided by 2 is the average power. Right? Now sketch a graph for current and power. Current going to be what shape? Current going to be a sine graph. So put the correct period, put the height, how much. This all information must given lah, because the values peak and the period, how much, this all carries 1 mark maybe. The shape is 1 mark. Okay. How the power graph going to look like? Power graph going to be a sinusoidal. Sine square. Going to be a sine square graph for a period. Power graph. The maximum is the peak value. T is the period. So hope everyone thought this method when you do this question. Any part you don't understand? Okay. I expected this your answers. Okay, the frequency V naught, the same method lah. Your I is sine, your peak value must be a sine squared graph. Okay, guys, any questions from here? No questions, Okay. So this going to be your homework. You can give a try. Okay. So try to do this question as homework, and the marking is already there. Try to understand it. So tomorrow we're going to do rectification, the last part of this topic, rectification. Okay. Any questions?
So
yeah.
Can you show the derivation for the peak power and average power again?
Oh, peak power, average power. This is the average power and peak power. So we need to prove this. So average power IRMS times VRMS. IRMS, VRMS, substitute the peak formula. IRMS is I naught over root 2, V naught over root 2. So I naught, V naught is the peak power. So I naught, V naught, you just replace with P naught, peak power. So peak power over 2 is average power.
Okay, thank you, sir.
Okay, class. So see you then. So see you tomorrow. Friday we'll be doing practical. Friday we'll be doing practical. So tomorrow we still will continue with this, finish this topic. Okay. Stop here.
Teacher.
Yeah.
If I didn't calculate the mean power using the formula just now, right? Then is the average power formula I naught V naught sine square omega t.
Again, what do you say, Shige? You want
Is
to
the
calculate?
actual formula for the power average power I naught V naught sine square omega t.
Sine squared. Ah, yeah.
Also, it's the same as the I naught
No.
V naught over 2.
No, this is not average power now. This is the power formula.
Oh, okay.
This is the power. This is not average power. Average power is constant one. So cannot have sign, right? This is power formula. That's power formula. Instantaneous power. Anytime you put, you get the power. Average power is fixed. Okay.
Okay.
Okay. Marwan, you said my connection is not good. A little or many times?
Oh no, just that one time for now.
Just one time.
That
Not frequent, right?
frequent.
Okay. Thanks. Bye.